I hope you do see the slides. Can you see the slide?
Yes.
Okay. So remember what was the error? The T model, this has to be 4. Okay. And this has to be, where is it? This has to be 4. Okay. So just fix those, and here it makes sense. Keep in mind, don't confuse. This is A, B, C, D. A, B, C, D. Okay? So in the last lecture, what did we do? I told you we have the pi model, and this is the A, this is the B, this is the C, this is the D. It's better to memorize them, but you have to prove them. One of my favorite questions that I'm planning to have is I ask you to do a pi model, T model, and compare both answers. Okay? The example that we started last lecture, it is a medium line, 200 kilometer. So what is the first step? The first step is to calculate Z, which is R plus J omega L, times the length of the line. Keep in mind that this should give you 7 plus 67.86 J ohm. Y is J times omega times C times the length, which is J times 0.0011. What's the unit? What's the unit? The unit is mho, okay? Or Siemens. I can just say Siemens. Clear? The VR is 380 kilo divided by square root of through, it's 219. The IR is 759. The angle is minus 36. If you do the calculations using the pi model, you should know that the B is the Z. So A equal to D, which is 1 plus ZY over 2. Go to the pi model. A is 1 plus ZY over 2. While C is Y times 1 plus ZY over 4. And here you should get them. You have to get them correctly. Calculators, I forgot my calculator, but you have to do it yourself, okay? So what is the sending end voltage? Sending end voltage is Vs, which is AVR plus BIR. You notice that it's 249 at an angle 8.98. It means it is this is 30 kilovolts higher than the receiving end voltage, and it has 8.98 degrees phase shift compared to the receiving end. For the electric current, the magnitude is smaller. It is 616 compared to 759, but the angle is negative 20 with respect to what? With respect to VR. VR is the reference, not IR. IR has angle minus 13. So maybe a trick question in the exam. What is the phase shift between IR and IS? It is minus 36 minus 18, which is plus 18. To calculate the VR, it's 30 kilovolts over 219, which is 13.59 volts percent. What does that mean? It means if you connect the load, VR would drop by 13%. If no load, VR, it has a value of Vs over A. If you connect the load, VR has a value. These two numbers are what? Remember, it's Vs over A, the voltage regulation. Something is wrong. Well, I think that we have to, I think for the voltage regulation, it's always Vs minus VR. There is no A. So the voltage regulation is Vs minus VR. So let's fix this formula. I apologize. I think that could be wrong. So let's fix the formula. Just put Vs minus VR. Okay? I don't think if you because if you divide by A, you get VR again. You agree with me?
Yes.
So let's keep it as it is, okay? So the voltage regulation is Vs minus VR over VR. I apologize for that. The transmission line efficiency, let's get the power factor angle at the sending end, which is theta Vs minus theta VR. It is 8 minus 18, which is 27. Cosine of that is 0.889. That's the power factor. You multiply that by Is and Vs magnitude times 3, you should get 409 as an input power. So what is the efficiency? It's 400, the receiving power over sending power times 100%. It's 97.6%. So what did we learn in this exercise? One is the formula for voltage regulation. It's Vs minus VR. As a matter of fact, this should be VR. If we were, it's Vs, which is AVS plus BIR. So the correct formula is going to be, if we want to write it as a function of VR, it should be AVR plus BIR minus VR. That's the voltage regulation, which is just Vs. Just put Vs, okay? Vs in magnitude, 249. Before we do this, let's look at the exercise here. The exercise here is 140 kilometer. So it's very similar. Just treat it as a short. And he wants you to do the IR for 3 different angles. 0.85 lagging, unity power factor leading. Here we have a typo. What's the typo here? Y. There's a typo in Y. What's the typo? the J. Forget the J. Okay? Do not forget the J. It's not only that, maybe it's better to write Z equal R plus JX here. Don't forget that in your calculations, please. We don't want to have unnecessary mistakes. So this is R, this is X, so Z is R plus JX. Y is JYD. Okay? As a matter of fact, it's even negative. It's a negative number. Is it negative? I forgot. No, it's not negative. It's J omega C, not negative. Okay. So if you do this exercise, part A is the same. Part 2 is you should get it for 0.85 power lagging, which gives you the angle minus 31. If you do the calculation, you should get this number, 158 angle 14. Now he's asking for the line voltage. For the Y connected, the line voltage is square root of 3 times the magnitude. You can add 30 degrees if you want. The unity power factor, the angle here is 0 degrees, so it will change Vs to be 137.6 angle 21 compared to 158. If you do leading, same for, for line multiplied by square root of 3. If you do Vs for 0.85 leading, the angle will be plus 31.8 and should give you 110 angle 25. So if you do the voltage regulation for 0.85 is 31.1 voltage regulation, 13.7 for unity power factor, minus 8.7 for the 0.85 PF lagging. So it's similar to synchronous generator. You have 3 different voltage regulations, positive for unity or lagging, negative for the leading power factor. Okay? And you can do the exercise with the efficiency. It's 93.6. The efficiency is only 4.85 lagging. So do this exercise at home. Any question about this exercise? Okay, fix the typos, okay? Then shortly we talk about the conductors. Transmission line conductors are normally made from aluminum with certain reinforcement. Copper is not usually used at high voltage because it's expensive. So we use aluminum with reinforcement. What is the reinforcement? Is a steel. So we have the conductors have 3 classification. ACSR, which is aluminum conductor steel reinforced. All aluminum conductor, all aluminum alloy conductor, 3 types of classification. They usually they have tables with birds' names for every size of every type of conductor. Now, conductors are made of aluminum strands, so the 2 outer layer aluminum, while the inside one is made of steel. So here you have 7 conductors made of steel, 30 conductors made for aluminum. The aluminum to transfer electricity, the steel is to give mechanical support. Okay? Not only that, this is a conductor. You put 4 of these bundles together using spacer, and you space them equally, or in a triangle, or in a bar shape, if you have 2 or 3 or 4. Why? To reduce the electric field strength. So you reduce the corona effect. So corona is the ionization of air around the transmission line. تأين الهواء جنب خطوط النقل. It has either a sound, hissing sound, or lightning. Please watch this video. I don't want to be blocked as usual. So watch this corona effect using this link. And then we have insulators. Insulators are made from glass, porcelain, and other synthetic material. Why? They provide support and isolation of electricity. And they provide high resistance for leakage current, and they withstand high voltage. So if you take the high voltage course, the professor, I think Dr. Omar Khan, will teach you about how to design them, how many layers you need, etc. Also, they have to carry the weight of the tower and line configuration together. Last thing we talk about is how we design towers. There is a whole civil engineering area responsible. We want to keep it at a safe height from the ground. And if the tower is too high, you need to put light bulbs for the airplanes. And you need to provide acceptable distance between phase conductors to avoid arcing effect, similar to corona. You don't want to have the two conductors touching each other or pulling towards each other. You can use wood or concrete for low voltage and steel for high voltage. And the design should be depending on the voltage level, the ground terrain, as well as the environment around it. Are you in a mountain area or valley or near the sea or in the desert, etc. So with that, we finished the transmission line chapter. Please study it for the fake quiz. Any question about it?
دكتور الفاك الكويز هيكون بس لهنا ولا
What?
الفاك الكويز هيكون بس للموديل 5؟
Yes. Module 6, my friend. It's not 5, it's 6. Transmission lines. Okay? When is the last lecture? We have 7 more lectures, right?
تقريبا.
Hopefully we have time. Okay. Now we have 20 minutes left. And I'm going to show you a presentation. So I'm going for a conference. And let me show you real quick the presentation. So do you see the slides? Yes or no?
Yes.
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 Okay. So the paper that I want to show you, it teaches you how power system nowadays are, what type of research people are doing. So ISGT, so IEEE, the Institute for Electrical and Electronics Engineers, Power and Energy Society. This is the name of the organization, حقت الباور, IEEE PES. ISGT is the name of the conference. It's Innovative Smart Grid Technologies in the Middle East, here in Dubai. So whenever you see a conference, it's under IEEE, United Arab Emirates section, IEEE Power and Energy Society. السوسايتي تحت الأورجنايزيشن. And then the conference اسمه Innovative Smart Grid, hosted by University of Dubai. So the paper title is The Wisdom of the Crowd. High Fidelity, يعني wisdom of crowd هذا حكمة الجماعات يعني. High Fidelity يعني high fidelity يعني يتحمل any issues. Classification of cyber attacks and faults in power systems using ensemble and machine learning. Ensemble is a branch of machine learning like decision trees, etc. And machine learning itself. So let's see what's going on. So the substations in power systems, like Aramco substation, for example, the one that they're building right now, it's evolving and they have cyber attack surface. Yani you can have false data injection, you can have replay, you can have denial of service. So we need accurate, fast detection and classification of both physical faults and cyber attacks to avoid misoperation. We have two types of issues, either faults, أخطاء في السيستم نفسه, or attacks بالdata. Currently, we have a renewable, which is inverter-based resources. We will study in the inverters in next week. And inverter-based resources, يعني solar cells, anything that requires an inverter, solar cells, for example. Or you can call it renewable energy sources, RES, two names. They alter fault characteristics by limiting fault current, degrading the reliability of the legacy protection. إيش معنى legacy protection؟ معنى traditional protection. Nowadays, Aramco substation, for example, uses these standards and they have sample values and they can be changed. Everything is now digitized. So what is the objective behind this research? One is to have high fidelity benchmark. We want to quantify how machine learning models behave when we train them for real-time data and offline data. So we have offline for training, real-time for operation, streaming. We want to expose them in the field readiness gap. We want to see which models have higher coverage, abstention rate. Abstention rate is when the machine learning classifier gives you a null answer. It cannot decide. Or anomaly accuracy and latency, تأخر. How much time we know if there is issue in our data, the voltage or current. And which crowd is wiser? Should we use trees more complicated ولا use more neurons في neural network? What we contributed in this paper is we have a high fidelity digital substation benchmark. We have now a model. We built a model for distribution that has 4.8 kilohertz Comtrade data. Comtrade data هذه الداتا حقت الباور سيستم 4800 كيلو هرتز معناها 4800 sample in 1 second. It means we have 4800 تقسيم 60 we have 80 عينة في السايكل الواحدة. We have streaming aware evolution pipeline. We have built moving average, confidence decision layer with abstention يعني abstain يعني يمتنع عن الكلاسيفاي. We have offline to streaming generalization gap. We want to compare. يعني let me ask you a question. شات جي بي تي لما تسأله على الأشياء القديمة يعني مثلا science ولا شيء, is it good or bad?
Good.
Good. لما تسأل عن أخبار اليوم, good or bad?
Bad.
So same story. لما تعطيه بيانات ديتا أنت مخزنها من قبل, he's good. بس لما تعطيه real time data جاية من الفيلد الحين وتقول له قرر هاللحظة, he is bad. Okay? And of course we want to have references for future work. So what is this system? This is a high fidelity. إيش معنى high fidelity? High fidelity يعني well built, high confidence. When I جي اسم software EMT electromagnetic transient test bed يعني مكان اختبار. في له chapter 6, في له PVs 50 kVA, في له batteries, battery energy storage 30 kVA 50 kVA, في synchronous generator. وين synchronous generator؟ قبل, not shown here because this is distribution. synchronous generator عند generation. طبعا we model ال PV, هنا في PV, هنا في battery. We model them as what? A synchronous generator to make things easy. So what do we have here? We have distribution line, we have one feeder, we have those boxes, they are merging units, وحدات دمج يأخذون بيانات voltage and current from this point to this point. Then we have feeder 1 and we have feeder 2. Feeder 1 splits into 2 feeders, واحد راح على PV واحد راح على solar cells, الباتري system, and الباتري تغذي load, capacitor bank, 3-phase load, single phase load. This is 1 phase, this is a 3-phase, this is 3-phase. Same story here, we have a load. So this is a fictitious system. Okay? We had some events. على سبيل المثال, we have single line fault between A and N, short circuit between A and N, between 1 to 150. That's an event. We give it 1 class ID. طبعا الماشين ليرنينج يعطيك يا 0 يا 1 يا 2. It tells you what happened and then you can use it to make your decision. Or 0 for a normal operation. في الستريمينج لما حطيناه في in action صار في عندي single line to ground fault, double line fault, CT ratio, we changed the ratio حقت current transformer or potential transformer. Of course, we prepared the data, we cleaned the data, removed the timestamps. And here we have 12 models of machine learning and decision trees. The most powerful ones, the ones that use the neural network, is the multi-layer perception, MLP. These are the good ones. Those are okay, good, but not much. طبعا ensemble, الانسامبل models هي family, عائلة, وفي موديل لكل واحد. التريند models are applied to 6-second streaming data set بعد ما سوينا لها training, post processing, where new sample are classified. We have an 80 samples, 1 cycle smoothing filter to stabilize moment-to-moment prediction, reduce the false spike, and we have a confidence-based decision layer. We have one additional layer to assign final class label. How many labels we had? 12. 0, 1, 2, 3, all the way to 17. 17. Okay? tells you which attack or which fault. Either we have an attack or fault. طبعا this is the math. This is if you're familiar with 315 Z-score normalization. Here I told you how we got number 80. It's for 4800 sample على 60 hertz. So it gives you 80 sample in one cycle. Here are probabilities, confidence score, or final decision with abstention. يعني حق الامتناع. Output label if confident, otherwise abstain. امتنع. إذا ما هو confident يمتنع. ما يسوي شيء. هذه الالجوريثم streaming inference with decision layer. This is how it's built. Initialize the buffer. P of length n cycle, which is 80. N over 2 is 40. This is n half, we call it. Each new sample populate with probabilities, put them in a MP. If length of B is 80, then take a mean, centered window of 80 samples, assign, get the maximum argument, get the maximum Q, put it in the confidence. If the confidence is greater than threshold, emit means release, else emit the other quantity with -1, and end if statement, and then slide out of the window. This is how the decision is made. These are the results for phase 1 offline evaluation. Most of them did well. Accuracy, precision, and recall. For streaming, because we have abstain, if you notice that in random forest and extra trees, decision tree, naive, logistic regression, AdaBoost, the coverage was no more than 50, below 50%. يعني it abstained 50% of the time or less or more. But if you see MLP or advanced technologies, especially MLP 99, 98, now, because it didn't abstain, it has multi-layer perception maintained very high coverage and confidence. طبعا احنا الموديل حقنا الconfidence has to be high, has to be accurate، لأن عندنا حق الامتناع. لو ما عندنا حق الامتناع كان يجيب العيد اللي تحت هذول. Clear? This is the best model that won the MLP, multi-layer perception. And here are the results, but I will show you this one. Here we have a fault between A and C. This is the current in this merging unit. هذه وحدة الدمج الثانية. Confidence dropped, and the anomaly class, it tells you it's a double line to ground. DLG is double line to ground, AC and N. Follow that there is a CT attack, change of data, and it tells you which class, which is class 5. Here it's class 10. Otherwise, it's normal operation. So what is the benefit? The benefit is you can use these information or this signal to open the breaker of the line and isolate your fault or attacked area. In this figure, we demonstrate the same during the system energization. We have an inrush current, we have IBR-driven isolation, and the model maintain normal. ما عندي أي classification لأن this is part of the normal process. When you connect PV, يصير في disturbance. That's normal. Energization, you don't want to classify it as a bad thing. So offline accuracy was misleading. The offline is always a trick. Have you ever heard about, oh, we train our model and it's 99%? Yes. But in streaming, with 3 ensembles abstained 50% or more of the time, while MLP kept 100% or 99 or 98% of the coverage. So what's the lesson? Use the MLP. Decision trees or old school ones are not good. It's not only that, we have a smoothing and confidence threshold. Stabilized predictions and reduced decisions, but the resulting MLP has a problem, conservation of misery. It takes 60 milliseconds. How many cycles? 60 divided by 16? 4 point something cycles, صح? A typical protection has a requirement. It has to make a decision in less than 50 milliseconds. 50 milliseconds يعني كم? 50 divided by 16. 50 divided by in 3.125 cycles. حنا عندنا 60 divided by 16. حنا عندنا 3.75 or more. So we need to bring this number here, 60. In the high fidelity merging unit system, the wisdom of the crowd favors a small crowd of well-tuned MLP neurons over larger crowd of trees, and a real world deployment will require models evaluated on coverage-based, abstention, anomaly accuracy, and latency under changing operating conditions in the grid topologies. What is the conclusion? Two major things to worry about. The offline is different than the field ready. Near perfect static accuracies hide major streaming coverage gaps. The MLP provides the best trade-off, high coverage, stable classification, and ensemble preserves precision but abstain more frequently. Doesn't tell you. So what's the future? Reduce it below 50. And the multi-zone leakage-free data set for joint classification. These are some of the things we can do in the future. So you can get the access for Dr. Imad Al-Din dataset, and you can play with it if you have any future projects. So any question about my presentation?
Good luck, Dr. All the best in the presentation.
Thank you so much. Do you have any other questions?
دكتور أنا تأخرت بالتحضير لأن النت كان سيء كثير.
القمي؟
لا دكتور.
لا عبد
اوكي
العزيز.
خلينا نحضر الحين.
دكتور
So let me start. We'll do it after the recording. But you have to stay. Any other question?
دكتور الكويز العادي متى بيكون؟
الكويز العادي the following Thursday, I think 4 December.